At the break of dawn, as the sky just begins to lighten, a familiar sound pierces the quiet, a rooster's crow, proud and persistent. It's a symbol of morning across the world. But what if we told you that this daily ritual isn't just a response to the rising sun? Roosters, as it turns out, are governed by a precise and deeply ingrained internal clock, one that anticipates the dawn rather than reacting to it. This internal mechanism is known as the circadian rhythm, a roughly 24-hour cycle present in almost all living organisms. It controls sleep, feeding, hormone release, and yes, even crowing. In roosters, this rhythm is so accurate that it continues even in the absence of external cues like light or sound. Scientists have long suspected that animals had internal clocks, but it wasn't until a landmark 2013 study by Tsuyoshi Shimmura and Takashi Yoshimura of Nagoya University that we got clear evidence of just how sophisticated a rooster's internal timing really is. In this study, researchers kept roosters in a controlled environment, exposing them first to a 12-hour dim light cycle. Even under these artificial conditions, the birds consistently began crowing approximately 1.8 hours before the lights turned on, mirroring how they crow shortly before sunrise in the wild. But the real breakthrough came when the researchers shifted the roosters to constant dim light, removing all visual cues that could indicate time of day. Despite this, the roosters continued to crow on a regular cycle, demonstrating that their behavior was not simply triggered by the light of dawn, but orchestrated by their own internal biological clock. This internal clock resides in a part of the brain called the suprachiasmatic nucleus, or SCN, located in the hypothalamus. It's the master timekeeper, receiving input from specialized photoreceptors in the eyes that detect changes in light. However, in the case of these roosters, the crowing rhythm persisted even when light cues were removed, proving that the circadian clock is capable of sustaining daily rhythms on its own, a phenomenon known as free running. But the science doesn't stop there. The rooster's crow is not just a personal alarm clock. It plays an important social function as well, particularly in the context of territorial dominance. In groups, roosters establish a packing order, a social hierarchy where one dominant rooster leads. In small flocks, it's almost always the top-ranking rooster that crows first at dawn, often with remarkable precision. The others follow, but only after he has called. When researchers removed the dominant rooster, the next in rank began crowing first, revealing that the timing is not only biological, but also socially regulated. In fact, even when subordinate roosters have the physiological ability to crow, they often suppress it in the presence of a dominant bird. This behavioral inhibition isn't due to a disrupted internal clock, rather, it's an adaptive response. Subordinates remain entrained to their own rhythms, but delay expression, a phenomenon known in chronobiology as masking. This maintains social order and reduces conflict, allowing the group to function smoothly without unnecessary displays of dominance. Further experiments showed that external stimuli, like sudden lights or the sound of another rooster's crow, can prompt the bird to crow. But this only works when the stimuli occur near the rooster's biologically scheduled crowing time. In other words, their internal clock creates a gating window, a period of increased sensitivity to stimuli, outside of which the rooster simply won't respond. It's not that the cues don't work, it's that the rooster's brain is closed for business outside its internal timeline. This is also where Askoff's rules, a set of chronobiological principles, come into play. One of the rules states that in diurnal animals like roosters, exposure to constant light can slightly shorten the internal circadian period. Under dim light conditions, roosters exhibit a free-running period of around 23.7 hours, slightly less than the solar day. This minor shift is biologically adjusted through daily entrainment to sunrise in the wild, but in laboratory settings, it proves how finely tuned and adaptable their clocks are. So why do roosters crow before dawn rather than waiting for the sun to rise? Evolution offers an answer. By crowing before sunrise, a rooster can establish its territory early, communicating dominance and presence to any rivals before the day begins. It's both a wake-up call and a warning. In evolutionary terms, the first one to call is the first to claim, giving dominant roosters an advantage in asserting control over their environment. It also synchronizes the group's activity, allowing subordinate birds to follow in a coordinated manner. Ultimately, the rooster's dawn crow is a symphony of biology, social behavior, and evolution, governed by a near 24-hour circadian rhythm, sharpened by anticipation rather than reaction, and moderated by social structure. The timing of this daily call reveals a level of complexity that goes far beyond folk wisdom. It's not simply about the sun, it's about internal timekeeping, behavioral regulation, and evolutionary strategy. So the next time you hear a rooster crow at the break of day, remember, you're not just hearing a bird greet the sun. You're witnessing a masterfully timed biological performance, one that's been fine-tuned by millions of years of evolution and choreographed by the invisible hands of internal time.